Okay, we are in Unit 2 tonight. Unit 2 is on construction math. So this might be a review for some of you, or it might be something that you didn't cover when you were in high school math class. But remember, in the construction industry of which we are a part, lots and lots of things are done in feet and inches and fractions of inches. So we need to know how to add and subtract and multiply and divide fractional numbers. So that is what we're going to work on tonight. If we were in most other countries in the world, we'd be dealing with the metric system and things would be in decimals and life would be different. But we are in the United States and we do things in our business in feet and inches and fractions of inches. So we need to make sure we are prepared accordingly. So again, Unit 2 is construction math and application. So what are we going to try to get done tonight? We are going to convert between improper fractions and mixed numbers. We'll see what that means in just a minute. We're going to add, subtract, multiply, and divide fractions and decimals. Okay, Pat, I think that was you. Got it. I guess you have in my business, a lot of times your boss calls and says, oh, I got to do this right away. So we call that a fire alarm. So looks like Patrick has a real fire alarm. So we're going to calculate dimensions. We're going to calculate areas and volumes. And then in the activity, we're going to try to relate, or you will try to relate these things that you've learned to actual problems that you will face in the world of construction. So what is a fraction? A fraction is basically a number, two numbers with a line between them. In this case, 9/16. So a fraction has a numerator and a denominator. The numerator is the number on the top of the line. The denominator is the number on the bottom of the line. So in the case of 9/16, it means that something was divided into 16 parts. And we are considering 9 pieces of that whole that's been divided into 16 parts. So again, in a fraction, the number on top is the numerator. The number on the bottom is the denominator. And please stop me and ask questions or put a question in the chat. It's important that we get this correct and that you understand this, because this is obviously something that you will build upon throughout your career in the construction industry. So a proper fraction is one where the numerator, or the number on top, is less than the denominator being the number on the bottom. So 7/16 is a proper fraction. 3/4 or 3/4 is a proper fraction. An improper fraction is defined as one where the numerator is larger or greater than the denominator. So 5/4 or 19/16, those are both improper fractions. Those are numbers that are greater than 1. So we're going to, as you see, simplify improper fractions and make them mixed numbers. Christoph, I hope you were able to find the quiz.
Yes, I did. Thank you.
Oh, good, good. Right, so we can change back and forth between whole numbers and fractions, right? If we have the whole number of 6, we can multiply it by 4 over 4 and turn it into fourths, right? We can multiply anything by 1 and it doesn't change the value of the number. So 4 over 4 is 1. We can multiply anything by 1 and it doesn't change. So that's how you convert a whole number into a fraction. Right? I thought there was a definition, maybe I missed it, of a mixed number. A mixed number consists of a whole number and a fraction. So we can convert mixed numbers into improper fractions. Again, remember, a improper fraction is one where the numerator or the number on the top is larger than the denominator or the number on the bottom. Right, so 3 5/8. We can take the 3 and multiply it by 8/8. So that becomes 29/8 plus 5/8, or excuse me, 24/8 plus 5/8 equals 29/8. So 3 5/8 is the same as 29/8. When I look at that, when I see the way that I would do this is that when I see the 3 and the 8 here, I multiply those two together and I add 5 to them, right? So 3 times 8 is 24 plus 5 is 29. So 3 5/8 is the same as 29/8. And we'll also have to go backwards, right? Convert mixed numbers back to convert an improper fraction back to a mixed number. We'll see that in a minute here. Right, so improper fractions can be reduced to a whole or a mixed number. Right, so 17/4 is an improper fraction. So we have 17 divided by 4 equals 4. So 4 times 4 is 16. We have 1/4 left over. So 4 1/4 is the same as 17/4. Pat, hopefully your alarm went off, or alarm was silenced in your building. Looks like you have a real fire alarm instead of a figurative fire alarm. So again, this is how you convert from improper fractions, how you reduce them to a whole number or a mixed number. We can also reduce fractions to the lowest denominator, right? 6/8. Since the 6 in the numerator is an even number, that generally indicates that we can reduce 6/8 to its form that has the lowest number in the denominator. So again, if we divide top and bottom by 2, we can reduce 6/8 into 3/4. And as you'll see in a minute, when we start adding and subtracting fractions, they all have to have the same number in the denominator for us to be able to work with them. So again, if anyone has any questions, let me know. If this doesn't make sense, let me know. Right? We can also increase the number in the denominator by multiplying, in this case, by 2 over 2, right? Just like we saw, we divided by 2 over 2. which is, in this case, we're going to multiply by 2 over 2 to change 5/8 into 10/16. And you'll see in a minute why we might want to do that. But again, multiplying by 2 over 2 is the same as multiplying by 1. Multiplying anything by 1 doesn't change its values. Sorry, Pablo, do you have a question? If I have, my apologies if I missed you in the chat. Yes, Pablo.
Yeah, my question is, and the denominator, and in this case, the 8 is only, or all the time is divide 2, or it's gonna change in another number?
Again, we're going to, generally speaking, we want to have the denominator. When we end a problem, we generally speaking want to have the denominator as the lowest number possible. So if the numerator is an even number, it generally speaking means that we can reduce the number to its lowest fractional form. So again, 6/8, we divide top and bottom, numerator and denominator by 2, we get it to 3/4, right? 3/4 is the lowest or the simplest form that we can make 6/8. And the reason we know it's the simplest form is because that 3 on top is an odd number. I can't divide that 3 by something else to make it lower. So that's how we would simplify. We'll see problems where we need to, if we have 5/8 and we want to add or subtract it with something else that has a 16 in the denominator, then we need to raise 5/8 to a higher number in the denominator. In this case, we're going to multiply it by 2 over 2, right? So 5/8 equals 10/16. 5 times 2 is 10, 8 times 2 is 16. If we had 5/8 and we had something else that was in 30 seconds, we would multiply top and bottom by 4, right? We get 5/8 would be 20 30 seconds, right? 5 times 4 is 20, 8 times 4 is 32. So why are we concerned with what's in the denominator? Well, we're concerned with what's in the denominator because when we are adding or subtracting fractions, all the denominators have to be the same. So I can't add 5/8 and 3/4 because the denominators are different. I have to convert those denominators to what's called the least common denominator. In other words, the lowest number in the denominator that I can convert all those numbers to. Once I convert everything to the least common denominator, I add all the numerators, I'll add all the numbers on the top and put that sum of the numerators over the common denominator, and then convert that back or simplify it to a mixed number if I possibly can. So let's see what that looks like. All right, so in this case, I have 5/16 plus 3/8 plus 11/32. I can't add those numbers directly until I convert them all to the same denominator. Again, since all the numbers in the numerators are odd numbers, then I can't simplify any of them, so I have to increase the 16ths and the 8ths to 32nds so I can add everything together. Right, so if I multiply the 5/16 by 2 over 2, 5 times 2 equals 10, 16 times 2 is 32, so 5/16 is the same as 10/32. And similarly with 3/8, right, I want to convert that to 32nds, so 8 times 4 equals 32, 3 times 4 is 12, so 3/8 is the same as 12/32. So now I'm in a position where I can add those things together. Right, I've converted all those things to, I've converted the 5/16 to 10/32, right? Multiply the numerator on top by 2, multiply the denominator at the bottom by 2, I get 10/32. The 3/8 I converted to 12/32. The 11/32 I left alone because 32 was the lowest common denominator. Once I add 10 plus 12 plus 11, I get 33. I get the improper fraction of 33/32, right? 33, we know it's an improper fraction because the numerator, the 33, is larger than the denominator, so I can simplify that and make it 1 1/32. So that is how you add fractions. Does that make sense? Again, just to review, we have to find the least common denominator. We have to convert all, convert all the fractions to that denominator. Sorry. Add the numerators and then convert from the improper fraction that is likely to result, convert that back to a mixed number. 5/16, 3/8, 11/32, 32 is the least common denominator. We convert everything to 32nds. We add the numerators. The result is an improper fraction that we convert back to a mixed number. Again, mixed number is a whole number and a fraction. Subtracting fractions, it's going to be essentially the same thing. All the denominators must be the same. We have to find the least common denominator and convert everything to that least common denominator. Subtract the numerators and retain the common denominator, and convert back to a mixed number if the result is an improper fraction. Right, so again, 3/4 minus 5/16, right? 5/16 is smaller than 3/4, right? 5/16 is just a little bit bigger than 4/16, which is 1/4. So we know we're subtracting a smaller fraction from a bigger fraction. So again, what's the least common denominator? Right, I can't simplify that 5/16 because the 5 on top is an odd number. So I have to convert the 3/4 into 16ths. Right, so I'm multiplying numerator and denominator by the same number. Sure. Um, back one slide to the rules. Is that what you're looking for, Gabrielle? Again, this is the rules for subtracting fractions.
Yeah, that's perfect. Thank you.
Yeah, and it's actually, if you happen to have the textbook, this would be on the top of page 27 of the textbook. Just like adding fractions is at the bottom of page 20 of the textbook. And for those of you that don't have the textbook, I sent you an email, I don't know, hour or so before class time, where I gave you these pages 20, 21, 22, and 23 that has the explanation and some practice problems, 24 as well, I believe. And then I also sent you the test your knowledge and the activity. So again, I didn't want to hold you up if you didn't happen to have the textbook. So that should be in your emails as well. So again, subtracting fractions, all the denominators have to be the same. We're going to find the least or lowest common denominator. I think I might have learned it as lowest common denominator. Subtract the numerators, retain the common denominator. And then if the result is an improper fraction, you can convert it back to a mixed number. So again, here's our 3/4 minus 5/16. Right, things that we in the construction business are going to be doing all the time. Right, whether we're a tile setter or a carpenter or a plumber or a pipe fitter or an electrician, no matter what you do, your dimensions are going to be feet and inches and fractions. So you got to know this stuff. So again, I can't simplify, or I can't reduce the 5/16 because 5 is an odd number, so I have to turn 3/4 into something with 16ths. So again, 3/4 times 4/4, right? 4/4 equals 1. I can multiply by 4/4 without changing the value of 3/4. So 4 times 4 in the denominator is 16. 3 times 4 in the numerator is 12. So now I'm going to have, what, 12/16 minus 5/16. The denominators stay the same. Subtract the numerators. 12 minus 5 is 7, so the result is 7/16. So, right, 3/4 minus 5/16. The result is 7/16. Let's tackle one or two more things here, and then we'll take a break. Actually, we'll do this one. So when we are multiplying fractions, we want to change all mixed numbers to improper fractions, right? Remember, a proper fraction is one where the numerator is less than the denominator. An improper fraction, the numerator is greater than the denominator. A mixed number is a combination of a whole number and a proper fraction. So we want to change everything to fractions, either change all mixed numbers to improper fractions. We're going to multiply all the denominators, multiply all the numerators, multiply all the denominators, and then we will again reduce to the lowest terms, reduce to the lowest denominator that we can. So let's see what that looks like. Right, so the example again, if you're looking in your textbook, this is in the bottom half of page 21. Right, so I have 1/2 times 3 1/8 times 4. So I want to first of all change everything to improper fractions. right? So 1/2. So 3 1/8 is the same as 25/8, right? 3 times 8 is 24 and 1 is 25. And 4 is the same as 4/1. So I've changed everything to fractions, right? 1/2 is a proper fraction. Numerator is smaller than the denominator. 25/8 is an improper fraction. 4/1 is an improper fraction. So once I've done that, I'm going to multiply all the numerators and the denominators, right? So 1 times 25 times 4 equals 100. 2 times 8 times 1 is 16. So I multiply those things together and I get 116ths. So now I want to simplify that 100 over 16. So divide the 100 by 16, that is 6th. And we have, right, we have 4 left over. So 16 and 4/16 can get simplified, excuse me, 6 and 4/16 can get simplified to 6 1/4. Do you need me to step through that again?
Yeah, Mr. Becker, why would we not change the half to an improper fraction?
There's nothing that you can change the 1/2 into.
Okay,
Right.
yeah, that's correct.
Right. So no, that's fine. No, ask questions. There's no.
No, I understand what you're saying now, that there's nothing you can change it to. That's
Yes, I think they should actually be. Let's be a little more specific here. Change all mixed numbers to improper fractions.
oh, okay.
And any proper fractions we don't do anything with, right?
Yeah.
I have
So
a quick question.
a proper fraction we don't have to do anything with. Yes, go ahead. Sorry, someone else was asking a question.
Oh, that's me. I'm sorry. I turned myself off by mistake. Can you tell me when you would actually be multiplying fractions in the context of like construction? Like, I'm just having a hard time imagining when you do that. Like, I can understand when you might need to like add or subtract fractions, but can you give me an example of when you'd have to multiply fractions? Just
Yes, that is correct. Actually, if you, Nicole, if you have your textbook, you can jump ahead or peek ahead, right? This will be a spoiler alert. You can peek ahead to activity 2-1 and right, question number 7 would be an example where we are multiplying fractions.
okay.
7 and 8 would be if you're a carpenter. These are, again, things that you would do all day long. Probably number 8 is a question that a carpenter would run across quite frequently, right? Taking a floor to floor distance and having to convert it into a set of, build a set of stairs from that.
Yeah. Okay. Thank you so much. I appreciate it.
Oh, you're very welcome. Again, when you look at the activities, think about the trades or the things that you might be doing in your career, whether you're if you're an architect or designer, this may be one set of things for you. If you're a carpenter or an electrician or a plumber or a pipe fitter, right? You're always going to be making measurements and cutting things up, right? I know the electricians have another set of things that I don't quite understand, which is bending conduit and what radius to bend it and that sort of thing. But again, these these problems will reappear in all the different things that you will do, which is why we want to make sure that we give you a solid grounding here. Any other questions? Why don't we do this? It's a couple of minutes before the top of the hour. Let's take a 10-minute break or so. So we will start again at 7 minutes after the hour, ideally, or probably 10 minutes after the hour. So get up and take a break, and we will resume.